Bought this little cheapy meter from eBay and $2.84 shipped. It's not bad at all. Of course, it gave it no instructions. There's D2, which is obviously for the current going through here through a shunt. There's this live ground. I suspect this is the voltage sensing. There's a current adjust and there's a voltage adjust. I suspect that's the power supply for that chip. Chip controls everything. Don't know what that is. I didn't look it up, and time is limited. Can't look up everything and do everything. So beyond that, other people have stripped this open. It's not too complicated. Those 7-segment displays here, they come straight through hole. That's them there. And there's just 7-second displays, and yeah, a flexible plastic with the printing, voltage, amperage, and this flexible plastic just seals up this piece. Others have opened it. I found one explanation as decent. Most people didn't really spend that much time on this device, or they just connected it up arbitrarily. One guy did a decent diagram on how to connect, and I'll link that in. But that said, I don't think he explained exactly why it's done this way. And I think I know why it is. This here comes in and plugs in here. When this goes in here, what we have is ground, and that ground joins to this ground. So ground is joined to ground, as is normally the case in any of these devices, right? So because ground is joined to ground, and then there's a shunt across this red essentially is essentially shorted to ground. So we cannot connect our current sensing to the positive side of our power supply. If we do that, we basically shorten our positive power supply down to our ground. Shorten out the power supply, that won't work. So essentially what we have to do is connect this to our negative in our power supply and use this as a negative out to the load. So it's more positive than this negative. More positive is relative here, but it doesn't short off to the positive supply of our power supply. So this because joins to the negative, this joins to the negative of the load. So the current flows through this, is sensed, and goes back to the load negative wise. We wouldn't need to connect this if we're using one power supply, because this and this is joined. We need power for the device, so we have to connect this to the positive side. And then we have voltage sensing, and this could go in different positions, but if we connect it straight up to the positive, it will check the voltage at that position in the power supply. I suspect again this can then be put in different position from this, in which case it will check the voltage relative to this ground, which is the same as this ground, and basically at that position in a circuit, wherever it may be. It does not necessarily need to be where this is, but if it's across the same and this is joined, what we're going to get is the voltage from the power source, ground, and current that goes through on this side. And I think that's why it makes sense how it's wired. But without that explanation, it's counterintuitive for this red wire to go to ground on the load. Counterintuitive, very easy to make a mistake. So let me just connect it up, make sure what I've said here works, and show it working. I mean that dodgy little housing to just kind of hold this piece of cardboard, just trying to keep this up in the air because it's troublesome to hold this with those wires behind. It's really meant to plug in somewhere. So what I've done is connected positive, negative to the power supply, negative up to the power supply, and this is red, positive 5 volts. And I expect that when you put this on, it'll come on, which it does. Alright, that's to be expected. There's 0 volts, nothing measuring, no current. What I'm going to do now is jumper here to our positive, and see, we should see our 5 volts. Expected when we jump up, we get our 5 volts. So that's our voltage source as we expected, as was predicted. So we now have voltage, no current join, no current read. Let's try to connect clean this motor, this little pump actually, and try to see if we can get the current measured from it. Before we connect, let's just make one little thing. As I said, this ground and that ground is the same, so what I've done is move the contact from this ground to that ground, and notice what we have, same 5 volts being read, which makes sense. Set now to measure. I've taken, this is our ground, this is our ground to load, which comes here to our load. So what we're going to do now is connect this to the positive and see if it works. And it does, and it's saying 270 ME. Makes sense. We're here in the whole pump here, so it's no point in trying to show it's working. Take it off, 0. Voltage still being measured. Let's disconnect our voltage sensor. Take that off, 0. Power is still running through from this side and this. It could run through also through this ground. Both are the same. The advantage of having these two separate ones is I can power this from an independent power supply, in which case if we were to do that, then this would be our voltage sense relative to that ground, and this would be all relative to this. That's why I suspect, actually I haven't tested it, but it makes sense. This is relative to this, which happens to be also joined to that. But if you're powering separately, that wouldn't matter.